The most important consideration for this problem is energy. What they're asking us is they're asking for a graph that effectively shows the mechanical energy for a system that includes the block and another system that includes the block and the spring. There is another important consideration here. Usually in AP Physics problems we can ignore friction, but here that they tell us that there is actually friction between the block and the surface, and that's going to be important to us. So let's look at the energy contained in each of these systems. So the block and spring system is fairly easy to picture. Um, you have kinetic energy when this thing is moving, and because you have a spring, you also have potential energy. And both of those, when you add them together, will equal the mechanical energy. The block in and of itself, since it is on a flat surface, it does not have any gravitational potential energy, and the only other type of potential energy we are responsible for knowing is spring potential energy. The block in and of itself does not contain that potential energy. If we look at the block alone, the only thing it has is energy due to its motion. So that means that its mechanical energy is going to be due to its motion. Now, if you remember oscillating systems, the block is going to move back and forth and back and forth. What that means is at its equilibrium point, it will have a maximum velocity, which means it will have a maximum kinetic energy. At its farthest point of displacement, it is going to have no kinetic energy because its velocity will be zero. Therefore, the kinetic energy at those points will be zero. So what you should expect to see with this is an oscillating graph. This allows us to rule out choice C because it has a constant mechanical energy for the block, whereas we know it needs to oscillate back and forth. So now what we need to do is we need to look at the energy of the block and the spring. The important thing here is the fact that there is friction. Friction, if you remember, is a non-conservative force. What that means is that it is going to decrease or change the mechanical energy of the system. Usually when we have our systems which don't have any friction, we would choose this answer because it has a constant mechanical energy. But since we have friction, we know we are going to have less and less energy the longer that the system is oscillating. This is an example kind of like what you would expect to see in real life. In real life, if you were oscillating a block on a spring and it was on a surface, you would see it move backwards and forwards, but eventually its motion would get smaller and smaller, and eventually it would stop. So this thing is losing energy as it travels. That rules out B, and we're left now with A and D. What we need to figure out is this a constant decay or is it varying, just like the change in the mechanical energy of the block? Well, keep in mind that for the block spring system, you do have kinetic and potential energy. When you do not have your energy in the form of kinetic energy, it's going to be in the form of potential energy. So you're not going to have this rapid up, down movement of your energy. Instead, you're going to have a gradual decrease like what you see in answer D. If you look then at the answer key, it does say that the mechanical energy of the block is only going to contain the kinetic energy of the block, and since the block's kinetic energy depends on its velocity, and that velocity is oscillating, so is the kinetic energy. Uh, However, the block and the spring system together contain mechanical energy composed of both the potential energy of the spring and the kinetic energy of the block. The combination of these two doesn't oscillate, it just decreases gradually. So that is your answer.